So we're going to find the definite integral using the limit of a Riemann sum, which is the definition of the definite integral. So we're going to take the limit as my number of subdivisions goes to infinity. And I'm going to go ahead and use a right-hand Riemann sum. So the picture I want to think of in this case is I'm taking my function 4x plus 6 and my interval from 0 to 7. I'm dividing my interval into pieces, and then on each of those subintervals I'm taking the output of my function times the width of the subinterval. We'll call the width of the subinterval delta x, and the output of the function f of x sub k. And so my Riemann sum is adding up these outputs times these change in inputs, or the width of the subinterval. Notice for this case we're subdividing from 0 to 7, and I said I wanted to do a right-hand Riemann sum, so all I care about is the right-hand input on each of these subintervals. I don't care about the left. So my k is going to go from 1 to n, where I think of my input 0 as x sub 0, my next input is x sub 1, and then x sub 2, x sub 3, and so on. And of course 7 is x sub n. So to be able to determine this Riemann sum, the first thing I need to figure out is who delta x is, or how big delta x is. So again, delta x is my change in input, or it's the width of one of these subintervals. So I'm going to take the length of the total interval, and I'm going to divide it by my number of subdivisions, in this case n. So delta x is 7 over n. And that's what I'm going to plug in here, is 7 over n. The next thing I want to make sure I know is what x sub k is. And k is what's incrementing from 1 to n. So again, I know that x sub 0 is my initial input, which is 0. And then x sub 1 is 7 over n to the right of 0. So it should be 7 over n. X sub 2 is 2 7 over n to the right of 0. So it should be 14 over n. X sub 3 is going to be 3 7 over n to the right of 0, so it'll be 21 over n, and so on. So I start noticing a pattern, and I see that x sub k is going to be k 7 over n to the right of 0, or 7k over n. A way to check that I got the right thing is to just check x sub n. So when I plug in n for k, I get 7, which is my right-hand endpoint. So that worked. So x sub k is 7k over n, and that's my input. My right-hand input on each subinterval. Just a quick aside. If instead I was going from, say, 2 to 9, my delta x would still be 7 over n because the length of my total interval is 7. But now x sub 0 is 2. So when I move 7 over n to the right of 2, I'm at the input 2 plus whatever 7 over n is. And then the second one would be 2 plus 14 over n. And x sub k would be 2 plus 7k over n. And I could still check my nth value that I have 2 plus 7n over n, which is 9. And that's my right-hand input. So that's how I determine what my right-hand inputs are. Now I'm going to use that to determine what my outputs are. So my function, f of x, is 4x plus 6. So I plug in x sub k, which I just determined was 7k over n. And now I'm going to simplify. So my input's 7k over n, my output is 28k over n plus 6. And that's what I'm going to put in for my output on each subinterval. So that gives me a formula for my right-hand Riemann sum. So my right-hand Riemann sum is the sum, where k goes from 1 to n, of 28k over n plus 6. That's my output. And then I multiply that by my change in input, or by the length of each subinterval, 7 over n. And we'll simplify that in the next video so we can take the limit as n goes to infinity.